Picture London in the 1850s, coal smoke in the air, gas lamps flickering, and then rising out of Hyde Park, an impossible cathedral of iron and glass. At night it glows like a lantern. Inside, pipes, fountains, plants, galleries, towers, and modern miracles arranged like a living blueprint of the future. But here's the question most people never ask. What if the Crystal Palace wasn't only displaying power, but generating it at all? Once you start noticing the water towers, the repeating metal ribs, the ventilation-like openings, the electrical geometry, you can't unsee it. And suddenly, the 1936 fire feels less like an ending and more like an erasure. Why would an exhibition hall need that much infrastructure? Why does it look engineered, not merely ornate? Before we jump to theories, let's anchor ourselves in what history says it was. Crystal Palace is usually presented as a monument to Victorian optimism, an oversized showroom for industry. Today we're testing a sharper possibility, that the structure also functioned as an energy system, collecting or guiding atmospheric charge, heat, airflow, or hydraulic pressure, and that the 1936 fire didn't merely end an era, it erased hardware we can't decode. That doesn't require belief. It requires curiosity and the patience to follow details. We'll treat this like a case file. Look at the building's utilities, compare design to function, separate documents from inference, and admit where the trail goes cold. It matters because the palace sits at the hinge of industrialization, early electrification, and mass spectacle. If one celebrated landmark had a second job, what else have we filed under decoration by mistake? So what's the official story? And where does it feel complete or incomplete? The official timeline is clean. In 1851, London hosts the Great Exhibition, and Joseph Paxton designs an unprecedented iron and glass hall, modular, prefabricated, fast to assemble, built to celebrate manufacturing empire and modern ingenuity. It becomes the temple of progress, a place where the public can walk through the future as if it's already arrived. After the exhibition, the structure is dismantled and rebuilt in Sydenham, expanded into a permanent attraction. Galleries, concerts, educational displays, fireworks, shows. For decades it functions as a national showcase and a mass entertainment venue until the night of November 30th, 1936, when fire consumes it, often explained as accident, sometimes linked to electrical faults and the difficulty of fighting a blaze in such a vast, airy structure. And honestly, that story fits the era. The Victorians loved spectacle, engineering, and symbols. Yet some questions linger at the edges. Why such extreme infrastructure for just exhibits? Why the emphasis on towers and water systems? And why the documentation praises the shell, while the operational guts feel strangely under-discussed? Now let's look at the features people point to when they say, this wasn't just a building. Start with the feeling you get from old images. The Crystal Palace doesn't read like a decorated shed. It reads like a system. The iron ribs repeat with machine-like rhythm. The spans are absurdly long, and everything is modular, as if the building itself is an apparatus you could assemble, disassemble, and reconfigure. Then there are the water towers. Not a quaint garden feature, but towering infrastructure, paired with fountains and high-volume water displays. Of course, Victorians loved spectacle, and water can be practical too. Fire safety, plumbing, cooling. But the scale pushes you to ask, why would an exhibition complex need pressure and supply on that level? What exactly was being fed, circulated, or stabilized? Look up next. Ventilation. A glass palace is basically a greenhouse, and anyone who has stood in one knows the heat can become brutal. Yet the palace's roofline and openings suggest deliberate airflow management, like climate control. Was it simply comfort for crowds, or the regulation of something more sensitive than people? Now place it in time. This is the era of telegraph lines, experimental lighting, electrical demonstrations, and public fascination with invisible forces. So when you see metalwork, spires, finials, and elevated elements that resemble antennae, the question isn't gotcha, it's were they purely ornamental or incidentally functional? Finally, the fire. Without alleging sabotage, notice how convenient any total destruction becomes. The guts vanish, the debate becomes hypothetical, and the building is remembered as a symbol, not a machine. Mainstream explanations can account for each feature alone. The alternative view says they were one integrated design. So what is the alternative framework that ties these pieces together? Here's the alternative frame. The Crystal Palace wasn't only a container for inventions. It may have been an invention. Not a power plant in the modern sense of turbines and wires, but a building engineered to collect, concentrate, and distribute energy in the environment. Airflow, static charge, what earlier writers called atmospheric electricity, even ether. The logic begins with the skeleton. Thousands of iron members form a continuous conductive lattice across an enormous footprint from end to end. In this view, the repeating ribs aren't just efficient architecture, they're a network. Then comes height. Those towers and elevated points could, at least in theory, interact with electrical gradients in the air, like oversized lightning rods or charge collectors. Add water, pressurized, flowing, everywhere, and you introduce a conductor, a coolant, and a mechanical medium at once. A fountain can be entertainment, yes, but it's also a visible output of pressure and circulation. What about the crowds? The hypothesis doesn't require secrecy. A public exhibition is perfect camouflage. You can run infrastructure in plain sight while everyone stares at the spectacle. If you were hiding an energy system in plain sight, wouldn't you wrap it in entertainment? And the fire? Options range from mundane to sinister. An accident made inevitable by materials and maintenance. A convenient reset for redevelopment and insurance. Or, for those who suspect suppression, the removal of a legacy system that didn't fit the emerging centralized grid. It's an extraordinary claim. The real question is simpler. Does the design invite this reading, or does it collapse under scrutiny? A hypothesis is cheap. Let's talk about what evidence could actually support or weaken it. If this is more than a hall, the proof won't be in vibes. It will be in records, diagrams, and the boring details Victorians love to file on screen. Start with Paxton's writings and contemporary engineering reports. Why the modules were sized as they were, how the iron was joined, what loads the roof could take. Then pull utility documentation, heating plans, ventilation notes, water supply and drainage maps, lighting contracts. Read them like a detective. Do these pages describe event support, or do they read like industrial operations? Next, go visual. Use engravings and photographs to tag recurring features. The towers, roof vents, long truss lines, pipe runs, and those finials people call antenna-like. Compare day shots to night shots. Where is the light concentrated? Do you see cable routes, generator houses, or access zones that look more like plant rooms than galleries? Ask, what's decorative and what's suspiciously functional? Then run skeptic-friendly plausibility checks. A glass structure overheats, so aggressive airflow and water could be basic comfort engineering. And atmospheric electricity is real, but usable power needs collection surfaces, insulation, storage, and transmission. What components are clearly present and which are missing? After that, zoom out to the era. Victorians were obsessed with invisible forces, telegraphy, early electrification, public demonstrations, patent culture. Are we uncovering hidden tech or retrofitting modern power plant language onto a multi-use entertainment complex? Finally, revisit the 1936 fire with restraint. Show eyewitness accounts, wind conditions, firefighting limits, flammable interiors, and possible electrical faults. Is the destruction suspicious, or simply a predictable disaster waiting to happen? If we take the strongest version of the alternative seriously, what changes? If even part of this building as machine idea is true, the implication isn't just a weird trivia fact. It rewires how we imagine technology's timeline. It suggests a parallel path. Infrastructure designed into architecture, localized and beautiful, maybe decentralized, where power, climate, and water systems are integrated into public monuments rather than hidden in fenced-off plants. It also raises an uncomfortable question about narratives. Why do some technologies become the future, while other approaches get dismissed as impractical, unsafe, or simply forgotten? And does it require a grand conspiracy to lose knowledge, or only economics, disasters, regulation, and a slow cultural preference for centralized control? So what would count as proof for you? Blueprints, patents, utility logs, eyewitness descriptions of outputs? If the palace was a machine, where are the measurable results? If it wasn't, why does its design keep inviting machine-like readings, even today? Let's bring it home. What can we say with confidence, and what remains genuinely unresolved? Here's where we land. The mainstream story holds up. The Crystal Palace was a genuine Victorian marvel, Paxton's modular glass and iron triumph, built to display industry and confidence, later reborn at Sydenham and ultimately lost to a catastrophic fire. That explanation is coherent, but the anomalies also don't disappear. The towers, the heavy water infrastructure, the machine-like repetition of the frame, the ventilation logic, the electrified atmosphere of the era, and the fact that the guts of the structure vanished before most of us could ask better questions. So the power plant theory remains exactly what it should be: intriguing, testable in parts, and not settled. Crystal Palace may have been a monument to progress, or evidence that progress took more than one path. Now I want your take. Which feature feels most explainable, and which feels hardest to dismiss? If you have diagrams, quotes, local sources, or photos, drop them below. And tell me what we should investigate next. Sydenham today, Victorian atmospheric electricity, or other exhibition buildings with similar towers?